All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still doing our human emotions detection module. Let's have a look at what we went over today. And we're still inside our ResNet module. And yesterday, if you recall, we went over the process of actually making parts of our, let me show you, making part of our model here, identity function, so that the rest of it can be fitted to the shallow section. This way we can make sure that those training errors don't increase as our models get deeper. So yeah, that's what we did yesterday, and today we're going to move forward with some light reading. So this is the training error of the deeper model shouldn't be greater than the training error of the shallow model, like I just explained. So this means that if we want to pass information from one point to the point, see 169 and 177. That's this here, like I showed you yesterday. We would this path permits us to copy the input to the output, like I showed you yesterday. So from this point here, we would create a pathway from our input to our output, and we wouldn't increase the training error. And of course, this extra space here created between that path will be our identity function. So that was all from yesterday. Today we are going to pick up. So let's say after passing through 20 layers, we get to a point where the values are almost zero, such that when the information passes, it will also be practically zero. Then it will be a path which at least restores the exact same input we have. So let's look at the diagram below. For example, let's say we have an input. This is our information, and these are the 20 layers we're going to pass through before we get to a point where the information is practically zero. So we're going to create a pathway here from this point to this point. This will be our input. This will be our output. And as you can see here, we created a space here, which will be known as our identity function. You can see it. This is a different representation of the above residual block here. Let me move up a little bit so you can see it. So you can see here it's pretty much identical. It's just laid out differently. We have our input, we have our pathway, and then you have our output here. And you can see here we have our input, we have our pathway, and then we have our output. And so this means that just as the author of the paper supposed in the example on line 148 to 155, let me show you that one more time again. In this example here, 148 through 155. So just as the author supposed in that example there, if we make our model or neural network deeper by adding a residual block, then there will be no increase in the error rate. And in practice, this instead leads to a decrease in the error rate, which is exactly what we want. That's basically what we went over today. Just more ways that we can actually make sure that we don't increase that training error by keeping everything the same, or not keeping it the same, but making sure we keep it in line with the shallow model and the deeper model. That's basically what we did. We did take a lot more notes, but I'm not going to go over everything today. But of course, I will pick it up tomorrow, and I will keep you posted every step of the way. For now, this is the Python Poppy. You guys stay Gucci.